Welcome to class. Our topic for today is laws of logarithm part 1. We are going to look at the background laws and also some background law known as theory of logarithm and also some laws governing logarithm. So let's start straight away. We're going to start with part A, which is known as background law. I term this logarithm to index form. You can also call it theory of logarithm. Look at it straight away. It says if log A base B equals to x, then a equals to base power x. Now I need to quickly say this, that this a here is called number. Anytime I have like this, log a base b, the a is called the number while the b is called the base. So if a logarithm of number a base b is equals to x, then a equals to x, the number equals to the base to the power of that x. Let's solve this is what is called theory of logarithm. Let's solve this example, e.g. if log x is 81 is equals to half, find x. That is, if log x is 81 is equals to half, find x. So in this case, our number here is x. Our base here is 81. So from the formula says that what the number is equals to the number a equals to base power x. So our number is x. So here I'm going to have x is equals to 81 raised to power 1 over 2. Following this, so I'm going to have x is equals to 81 actually means 9 raised to power 2. Close the bracket, 1 over 2. And this will give us, this cancel this, and we get 9. Look at another example there. In this case, everything here, this 4 raised to power x plus 1 is our a, like this. This 2 is our base. Then this x, this 4 here is our x. So what is the formula? If log a base b equals to x, then what? A equals to b raised to power x. So our a here is what? 4 raised to power x plus 1 is equals to 2 raised to power 4. And I'll apply lowest common base. The lowest common base of 4 is 2 raised to power 2, close the bracket, x plus 1. And I say I have 2 raised to power 4 here. So that will give us 2 raised to power, remove the bracket, 2x plus 2 is equals to 2 raised to power 4. So those of indices, looking at this at the same, cancel them out. 2x plus 2 is equals to 4. 2x is equals to 4 minus 2. 2x equals to 2. Then x equals to 1. So let's move straight away to the laws of logarithms. The first law of logarithm is addition law. Addition law says that if log a base b plus log c base b, provided they have the same base, provided they are of the same base, they have the same base b, log a base b plus log c base b will give you log a times c base b. This is what is called, this is what is called addition law. Instead that is plus that is between them. Let's give an example. If I have log 3 base 2 plus log 4 base 2, this will give me automatically log 3 times 4 base 2, and this will give me log 12 base 2. So that is how to apply the first law. The second law, subtraction law, almost the same thing, but just change the sign. We have log a base b minus log c base b. No, the other time I have times here, so this one will give me quotient. I have division here. That will give me log a over c base b. This is called subtraction law, or some books call it quotient law. Let me give you an example. If I have log 20 base 3 minus log 5 base 3. Consider they have the same base. So this will give me log 20 over 5 base 3. And this will give me log 4 base 3. And that's the end of that. So this is what is called subtraction law. I coined one. You can combine this first law and second law together and call it mixed operation. Look at it on the screen here. If I have log A base B plus log C base B, if I have addition, I will multiply. That's log A times C minus log D base B. If I have a minus, I will have division. So this is the mixed operation. So this statement here combine all of the combine first law and second law together. Let's see an example to that effect. E.g., if I have something like log 5 base 7 plus log 6 base 7 minus log 2 base 7. Consider that I have addition and also have subtraction, and they are all of the same base. So this will give me log 5 times 6, that is the addition here. The minus there will turn to quotient over 2 base 7. And that will give me log 2 here 1, 2 in 6 3. That will give me log 15 base 7. That's that. So let's go to the third law. The third law is what is called power law. If the number is raised to a particular power, if log A raised to power C base B, that will give you, this C will come down to give you C log A base B. Let me give you an example. Let's say I have something like log 8 base 3. Log 8 base 3 will give me something like log, I can change 8 to lowest common base, 2 raised to power 3 base 3. And this will come down, becomes 3 log 2 base 3. That's an example there. There's another law called same base, same number. If I have log A base 8, will give me what? 1. Let me give you an example. If I have log 10 base 10, will give me 1. If I have log 2 base 2, will give me 1. Number 5 law. Logarithm of 1 to any base is 0. Log 1 base A is 0. E.g., if I have log 1 base 10, will give me 0. Log 1 base 5, will give me 0. So if you press the calculator, logarithm, just press log 1 in your calculator. Your calculator is automatically in base 10. So log 1 in your calculator will give you 0. Number 6 is the power of the base law. In this case, it is the base that is having the power. Look at this. We have log B raised power C, log A base B raised power C. That means the base is one that is having the power. Look at it. That will give us 1 over C. The reciprocal of C is 1 over C. So 1 over C log A base B. Let me give you an example. If we have log 16 with 2, like you know that with 2 is the same thing as 2 raised power half, law of indices. So this can give us log 16 raised power 2 raised power half. Now our C in this case is half. What is the reciprocal of half? If I have half, the reciprocal of half is 2 over 1. So this will give me 2 log 16 base 2. That's the idea. So if it is the base that have the power, you are going to find the reciprocal of that power, that base, 1 over C. Then you have the other one left. You have log A base B left. So the reciprocal of 1 over 2 is 2 over 1, which is 2. So I have log 16 base 2. And this will give me 2 log, if I change 16 to lowest common base, 2 raised power 4 base 2. And if the 4, using power law, using this law here, this log. This other 4 come down, become 2 times 4 log 2 base 2. 2 times 4 is 8 log 2 base 2. Log 2 base 2 is 1, so 8 times 1, that gives us 8. So the answer to that question is 8. Number 7, reciprocal log. This is like saying the reciprocal of 2 is 1 over 2, right? So if I have log a base b, the reciprocal of log a base b will actually give us 1 over log b base a reciprocal. So e.g., if I have log 3 base 2, the reciprocal of log 3 base 2 is more like 1 over log 2 base 3. So that's that about that. And for you to know that you are correct, if you cross multiply, you have log 3 base 2 times log 2 base 3 equals to 1. Just like if you multiply 2 with the reciprocal, 2 times r, you get 1. So you can leave it like this form, or you can leave it in this form. You are still very much correct. Okay, number 8 law. That law is called the change of base law. So let's say you have log of a base b. I want to change it to a logarithm in base c. It's very simple. Look at it here. That will give us log a base b equals to log a base c divided by log b base c. You just share the number and the base, and then introduce your base. Introduce the new base. So the number initially is a. So that will be log a base c divided by the base initially was what? Log b. Introduce the new base c. Look at the example here. If I want to change log 2 base 3 to a logarithm in base 5, the new logarithm is base 5. So the old number was 2, the old base was 3. So that will have given me log 2 base 5 divided by log 3 base 5. So these are some of the laws. Let's quickly see if we can solve 1 or 2 questions before we end the class. Look at this question here. Find the value of n if log 4 base 2 plus log 7 base 2 minus log n base 2 equals to 1. This is very easy. Here you're going to apply the mixed operation law. I'm going to apply the mixed operation law. I'm going to apply the mixed operation law. Log a base b plus log c base b minus log d base b equals to this. So I'm going to apply that law to solve that question. Let's apply that law. So here I'll apply, just say recall that what log a base b plus log b log c base b minus log d base b. You actually give us log a times c over d base b. So I have addition here. So this will give me log 4 times 7. The subtraction here minus over n base 2 is equals to 1. Now the 1 in this case, our logarithm is in base 2 here. So the 1 in this case will give us log 2 base 2. Don't forget that log a base a is 1. So log 2 base 2 is also 1. So what do you observe here? You observe that log to the base of 2 is on the left, log to the base of 2 is on the right. So you can cancel it. So it remains 28 over n is equals to 2. And that gives us 28 is equals to 2n. From there, I will have n is equals to what? 14. So this is where we'll stop for today. So you can check our next video, part 2. That is where I will solve a whole lot of questions on logarithm, applying all the laws that have been stated.